Chapter 7, 7.1.4. There's actually one more section in 4. I thought there was only 3. We'll do a brief review of each section, and then we'll talk about public and private addressing. So you should be able to convert, structure an IP4 address. So you should be able to determine the network portion, host portion, and understand what a subnet mask is. Unicast, one device to another. Broadcast, one device to all of them. Multicast, one device to a select group. And then we're going to finish up today talking about public, private, and reserved IP addresses. IP address structure. Whenever you see an address, for example, we were looking at an address like this, 192.168.1.10. Okay, let's say that address is an address on a router, on a device at somebody's home. Okay, if I did a /24, you should be able to tell me then how much of that's the network address. /24, prefix bits, that means 24 bits. So there's 8, 16, 24. This part's the network, this part's the host. So then in this, if I did 192.168.10/24, eventually you're going to get pretty good. You're going to say, okay, I know that's the network. And if the host is 0, then this altogether is a network address. Yeah, network address. If I was to give you this one, 192.168.1.255, now you see that host address is 255, which if we were to write that out, that'd be 8 ones. Now we know this is a broadcast. Alright. Unicast, broadcast, multicast. Unicast. Communicating to one other device. Maybe this would be a server. This is a client. Now you're going to send a message to the server, a URL, say I need a web page, and then the server sends a web page back to you. Unicast. A lot of things on the internet function in unicast. Broadcast might look like this. We might have a client, and the client needs, it's going to, let's say, ping an IP address, but what it needs are MAC addresses, so it could send an ARP, which would be a broadcast, then to all the devices on that particular network. And then they would all send, or they could send a return depending on what the broadcast was about. Multicast, you send it and it goes out into a network, and it only addresses those that belong to the multicast. Even though there are lots of them out there, it only goes to those that it's directed to. that belong to the multicast. There was a way, and you know, when you put, let's say, a packet into the internet, that one packet can work its way through the internet until it hits a particular router that might split it up to multiple locations. Alright. Types of IP addresses. Okay, so we're going to talk about private IP addresses, and there's a whole, you know, some ranges of private addresses, and we'll learn those as time goes on. And we'll talk about public IP addresses. Typically, have to be public addresses that are used on the internet. In fact, the internet, if you have an address in the internet, it has to be a public address. You can't put private addresses. They cannot go to the internet. They can't. But they can work fine within your own network, as long as you're not letting any of that traffic go to the internet. So we have these ranges of addresses. These addresses here, the 10 addresses, this group of 10 addresses, they're private. This group of 172.16 up to 172.31, they are private, and then the whole 192.168 are private. So you can see here, in internal networks, we can be using private addressing. You know, a lot of times you'll see that on your home network. If you check your IP address at your home, a lot of times those home routers will use 192.168. We have a loopback address. We have local link addresses. Sometimes if you don't get a connection, like your cable's unplugged or something, you will notice you'll get one of these 169 addresses. And we have testnet addresses. And they give an example here of pinging the loopback address. Going back in history, addresses were classified. We had A addresses, B addresses, and C addresses. You will run into people that will still reference those, and they give the ranges here of where they go. So, for example, you can see there's a whole block of C addresses that are private, that 192, 168, and so forth. And there's also a block of B addresses that are private, that 172.16, so forth. And there's a block of A addresses. Those 10 addresses are private. And all the rest of the addresses here then are public. Classless addressing. We have moved away from managing within those classes to classless interdomain routing. Sometimes that's pronounced CIDR. A lot of times it's pronounced CIDR. Create a new set of standards that allows service providers to allocate IP version 4 addresses on any address bit boundary. So any prefix length, instead of the old boundaries of A, B, and C. This is becoming so obsolete we hardly need more. Groups that assign the addresses so we don't get any of them mixed up. Talk about that when we get to IP6 addresses, which will be the next topic. So we're done.